this video, we're going to be looking at simplifying rational expressions. So first, let's just go over what a rational expression is. Essentially, we're going to have a ratio, and a ratio just means we're basically going to have a fraction, okay? So we're going to be dealing with some type of fraction, but on the top and bottom, we're essentially going to have something that needs to be factored or maybe needs to be divided, something like that, all right? So let's go through the steps real fast of simplifying a rational expression. So the first thing we want to do is we want to factor anything that can be factored. So factor anything that can be factored, and I'll obviously let you just sub that in. So now, anything that you have that's a monomial, which just means it's one single term, you're going to use your exponent rules for that. So use exponent rules, all right? And then the last step is we're going to cancel or eliminate, I'll just say cancel, any, which I'll show you why in a second, but let me make sure I can spell cancel right. So cancel any common binomials, which we'll look at that. Basically, it means this. If you have like an x minus 2 over an x minus 2, those would be a common binomial. Anything divided by itself is 1. So we could cancel those and say this equals 1. It's essentially what that third rule means. So now let's actually look at some problems. And before we continue, within this, we're going to do quite a bit of factoring. Okay, you just saw in that first step, we're going to do factoring. Now, I've uploaded another video that's pretty much a complete guide to all the factoring that we'll need for this. So I would be sure to go check that out. I'll probably link it in the description as well, just so you can have it. And then as always, if you enjoy this video, if it helps you, like, subscribe, all that. So let's look at an actual problem, and we'll start off with more basic problems, and then we'll progress from there. So this first example says 20x to the 6th divided by 14x squared. Now, we have a monomial, one term on the top, a monomial, one term on the bottom. So all we have to do is divide this. There's nothing really to factor here on the top or the bottom, so we're just dividing. Okay, so we would say 20 over 14 would become 10 over 7. And then remember, when you divide and you have exponents, we subtract those exponents, and that would go on the top. So x to the 4th. So there you go. There's a quick example. And this is all stuff that we've done from the past, or at least that I've gone over from the past, but you probably have too if you're new to these videos. So the first example, probably not too bad. So let's make it a little bit more difficult. So 6k minus 36 over k minus 6. So now, why don't you do this? Why don't you pause and see if you could factor everything that can be factored and then cancel common binomials. All right, so if you look at the top, if you notice, we can always check for a GCF first, and that's what I would recommend do, because if there's no GCF, who cares? You'll just move on. So we do have a GCF here. We could factor a 6 out, and we would be left with k minus 6 on the inside of our parentheses, and on the bottom we have k minus 6. Now, as long as this 6 is divided by this parentheses, we essentially can say, okay, that means this k minus 6 and this k minus 6 can cancel because they're common binomials. All right, so as long as you're multiplying everywhere, we're good to cancel those out. All right, so then that just leaves us with 6, and that would be our answer. Now, typically, the problems that are more advanced aren't going to just reduce to give you a number. I mean, it can happen, but I wouldn't get used to that being some kind of pattern there where we got just a single number as our answer. All right, so let's continue. Once again, we're going to start making this more difficult as we go. So we have y plus 8 over y squared plus 2y plus, or actually minus, 48. Now, on the top, here's what we're going to do first. We're just going to try to factor everything that can be factored. And on the top, you can see y plus 8 is just going to be y plus 8. Okay, there's nothing to factor out. There's no GCF. There's no special kind of factoring for this. Now on the bottom, we have a trinomial, which means there are 3 terms. 1, 2, 3. And we have a special type of factoring for this pattern. Y squared plus y, well 2y, and then a number. All right, if you remember, which once again, I'm going to go through this part quick because it's in a previous video. But if you remember, when we have 3 terms, if there's just a y squared or a 1 in front of y squared, we can look at the last number and we can say, okay, what 2 numbers multiply to give me negative 48 and add to give me negative, or actually positive 2. All right. Once again, if you're unfamiliar with this, go check out my factoring video. It's pretty much a complete guide to all this. All right, so now let's see. We would choose 8 and negative 6. We would need positive 8 and negative 6 to make a negative 48 when they multiply, and then 8 minus 6 is 2. All right, so then here's how it factors. We have y plus 8 times y minus 6. So now, once again, notice that this top part doesn't have anything else on the outside, like nothing else is there. It's just y plus 8, so it's like one binomial. And then on the bottom, we're multiplying in between these 2 parentheses, which means we're free to cancel this common binomial. But here's where you have to watch out. You have to remember that this is dividing something by itself. So we're left with 1, not 0. So our answer would actually be 1 over y minus 6. All right. So now let's keep going. Let's try to progress even further. And actually, I'll let you, or hopefully you're doing this on all these, but see if you can give this one a shot on your own. 2r to the second minus 2r minus 40 all over 8r plus 32. I suggest you start looking for a GCF and then see if you can go from there. All right. So let me find a color I actually want to use. All right. So now if you focus on the top, we can take out a GCF. We could say 2 could factor out of each of these. So it'd be r squared minus 2r minus 20. Okay. And then on the bottom, we could actually factor out an 8. So we would have 8 parentheses r plus that would be 4. All right, so now we factored out this part, but we can actually go further if you look inside of our parentheses. We still have 3 terms, a trinomial here, and it's r squared, r, and then a number, which is typically a tip-off that you could factor this. So let's try to do that. So now we have 2 on the outside still. We need 2 numbers to multiply to give us negative 20, which that's a terrible arrow. That was an attempt, at least. All right, so 2 numbers that multiply to give us negative 20 and add to give us negative 2. And actually, that wouldn't be a negative 2. I wrote that down wrong. Even if I said it right, I don't even know if I said it right, but it doesn't matter. When we divide out this 2, we'd be left with an r here. There we go. All right, that makes it all better. All right, so now, once again, we already have our 2 out here on the top. Now, let's see what 2 numbers would multiply to give us negative 20 and add to give us this negative 1. And that would be, let's see, a negative 5 and a positive 4. So we would factor this r minus 5 times r plus 4. All right. And then on the bottom, we have already completely factored this, so there's nothing else to factor. So now, watch what happens. Once again, if you notice on the top, 2, this parentheses and this parentheses, they're all being multiplied. And on the bottom, 8 and r plus 4 are being multiplied, which means anything that's the same on the top and the bottom can cancel. So first of all, these r plus 4s can cancel. So I'm left with 2 r minus 5 over 8. Now, 2 over 8 can reduce because, once again, everything here is being multiplied. So if we break down 2 over 8, that would be what? 1 over 4. So we'd be left with r minus 5 on the top, 4 on the bottom, and this would be fully reduced. All right. So now let's look at another one. I'm going to try to show you as many examples as I can without completely going overboard. All right. So now let's look at this real quick. here's I'd say this is an example that you don't see a lot, but you can see on occasion. Let's say I give you p squared minus 49 all over 7 minus p. Now, if you remember, the top part we have p squared minus 49. If you have two perfect squares that are being subtracted, you can factor this using difference of squares, which means we do the square root of p squared, which is p, minus the square root of 49, which is 7, and then we repeat that, but now we say p plus 7. And then on the bottom we have 7 minus p. Now, you may look at this and say, well, there's nothing on the top and the bottom that are the same. However, there is a little pattern with this that I'll show you real quick. It essentially looks like this. If you have a minus b over b minus a, which essentially means this. If you have two numbers that are being subtracted and all you do is flip those numbers around, so we would move 7 to here, p to here. If you ever have that and they're being divided, those can cancel, but instead of it giving you 1, it gives you -1. And I'll show you why. Okay, so that's kind of the definition. But let's look at why that happens. So first of all, let's move this p to the left and let's make this plus 7. So I have negative p plus 7. Now, if I factor a -1 out of this, it would become positive p minus 7. Now you can see that this is the exact same as this. So they would cancel here and here, but once again, this -1 is still left on the outside. Okay, so that's the part you have to pay attention to, which hopefully, if you're doing this, you see more examples of this. But that means we can cancel these two, and we get a -1 here. So we can say -1, or I'll just say negative times 7, nope, it would be p plus 7. And then if we wanted to, we could distribute that. I guess you don't have to if you don't want to, but I'll do it just because it will probably look nicer. All right, so that would be our final answer. So now, once again, let's continue. Let's dive into this further. And this is probably going to be one of the last few examples because this is where the factoring gets more difficult. Essentially, while you're just simplifying, the most difficult thing is when the factoring gets more difficult, to be honest. So let's look at this example. 6n to the second plus 8n plus 2 all over 2n plus 2n squared minus 2. All right, so now let's first start this by factoring, and let's check for a GCF. So now let's look at the top. Do we have a GCF we could factor out? Yes, we do. We could divide 6, 8, and 2 by 2. So that's going to leave us with 3n squared plus 4n plus 1. On the bottom, do we have a GCF? Yes, we have 2. So we could factor out a 2. We're left with n squared minus 1. Now, here's what you could go ahead and do if you wanted to. Since these 2's are on the outside, that you could go ahead and cancel those. I'm going to leave them just to make sure that we don't skip any steps. But if you wanted to, I don't see an issue with canceling those out here. But I'm going to leave them there. So now, let's look back in the top parentheses. So we have 3 terms, and we have this pattern n squared, n, and a number, which means this needs to be factored. However, if you remember, this 3 being here creates a little speed bump for us. So once again, to fully check out this, the way you do this, you're going to need to go back and look at that factoring video that I put up, because I will, it's just going to take too long to try to reteach this fully. Essentially what you do is you multiply this 3 down to the end, and then you come back and divide that 3. And it ends up leaving you with this. 3n plus 1, that would be your first factor, times n plus 1. All right? Now, on the bottom, this is a lot nicer for us. We have this 2 still out here on the bottom, and we can factor this on the inside. N squared and 1 are both perfect squares, and we're subtracting, so we can do difference of squares. So we can say n minus 1 times n plus 1. All right, so now let's cancel everything that is a common binomial first. So these n plus 1s are going to go, so those are out. Now these 2's are also going to cancel because 2 divided by 2 would just be 1. So we're left with 3n plus 1 over n minus 1. So I would imagine, once again, if you struggle with this problem, it would probably be this portion right here. And once again, the good thing for you is I have a video that essentially covers that entire type of factoring. So I would check that out because it will help you a ton. All right, so now let's do one more, just because I know you may want another example. We're actually going to combine two things, two of the most complicated parts of this. So 45 minus 5w over 3w squared minus 28w plus 9. All right, I wrote that a little sloppy, but I think you get the idea. All right, so now let's do this. We're going to double check to see if we have a GCF. Let's start with the top. I think we could factor out a 5 here, and you could factor out a -5, I guess, if you wanted to. I'm not going to because I want to make a point out of this. So let's just factor out a 5. We'd be left with 9 minus w. All right, now, once again, check for a GCF on the bottom, but here's the issue. 3 would be the biggest thing we could divide out, and 3 doesn't divide 28. It would divide 9, but it wouldn't divide 28, so there's no GCF here, which, once again, go back and look at the factoring video I've put up, but you'll have to multiply this 3 down here to the end, then you'll have to come back and divide that 3 once you find your factors, and I'm going to go ahead and factor it because it will be a lot easier that way. So 3w minus 1 and w minus 9, that would be our factors. Now, here's a situation that we've gone over just a second ago. Notice that on the top and on the bottom, we're multiplying everywhere. These two parentheses are the exact same except the 9 and the w are swapped, which means we can cancel these two, but we're left with a -1. So you would have to make sure you make this a -5 on the top. So it would be -5 over 3w minus 1. And that would be our answer. So once again, it will be extremely important for you to be able to factor. And I'm going to link that factoring video in this description. But please be sure, even if you don't go watch my video, I could care less. If you need to talk to your teacher, whoever it is, you need to make sure that your factoring is pretty solid, because if it's not, these problems will create issues for you. So make sure we get some practice on our factoring. It could be my videos, it could be someone else's videos, whatever you got to do.